Yes, welcome to our discussion. So today we are going to look at different laws which are going to be applicable whenever we are trying to deal with this concept of logarithmic uh, functions. And in this case, of course, we're going to see that these different laws of logarithms are going to be inferred from the laws of indices that we have discussed in one of our videos. So we're going to see that we're going to use different representations. And in this case, we're going to use general representations for the numbers A, B, and Q, whereby these are going to represent what we call just like just like in our previous discussions with this, that these are going to represent basically what we refer to as integers, and therefore are going to assist us to try and represent the different forms of these specific laws of logarithms. So if I start with, we're going to see that there are different ways in which we are going to represent these specific or particular laws of indices. And the first one we're going to see, and just give it as number one, we're going to see that a logarithmic function that is represented as a log to the base A with a product of P and Q. This is going to be equivalent to or given as the log to base A P plus the log to base A Q, and therefore give us a law which states that for the product of a logarithm of a product of a number that has been given the log to base A of that specific product, then the product for that is going to be the individual logs for those particular numbers for this specific case for the product. In that case, I'm trying to explain this particular case whereby we have the product of two numbers for P and Q. Therefore, if we have a logarithm of those combined numbers, then we're going to see that for us to find the logs, it's going to be addition of those individual, the logarithms of the sum of the logarithms of those individual numbers, which is going to be given as such. Now, suppose we have a log of a number which is a rational number, log to a base A of a rational number P over Q. Then this is going to be represented as log to base A P over log to base A Q. But in this case, we are going to have it given as log to base A P minus log to base A Q. So therefore, this is going to be a representation, just give it a fast such. So it's going to be, so this is basically going to show us that for multiplication of a specific two different numbers, if we are finding the logarithm of a product of two numbers, then it's going to be the sum, the logarithm is going to be the sum of those specific numbers to the similar base that we have seen. And if we are having a division, then we're going to have a subtraction, or maybe the difference between those two numbers for the numerator and the denominator. Those are individual logs for those two numbers. I hope that that one is going to be, of course, easier for us to understand. So in case we have a logarithm to base A of an exponent, which is P raised to Q, then this is going to be represented as Q is going to be used as a coefficient, and then log to base A P given as such. So these are three specific laws for addition, for multiplication, and then this is for division, and then this is for exponents, or a number that is raised to a power. This is how we're going to generate logs of numbers which are appearing with this specific nature. So suppose we have a log of a number. So this is rule number 3. So suppose we have a number which is given as a fraction, or the power or the exponent is given as a fraction, then we're going to have it represented as this is number 4. So log to base A of a number P, which has been given the exponent of 1 over Q. So we're going to represent this one as, still we're going to use this one as 1 over Q log to base A P. So this one, for numbers which have been raised, of course, we're going to see that it's going to be given as a coefficient, which is going to start, and then we are going to have a log p given as such. So number 5, we're going to have another format whereby the log to base a of a number 1 or a unit is going to be 0. So if we try to give a relationship for this from the 0 or a unit exponents, this is going to have an implication of a base which is raised to a power or an exponent, which is a raised to an exponent. It's going to give units. So I'm just giving this one as a reminder. But of course, for laws of logarithms, that is how it's going to stand. So we are going to have the last one, which is number 6. So number 6 is going to state that a log to base a of a, this is going to be 1. And from this one, a reminder as well, we can say that a raised to power 1 is a. So therefore, those are some of the laws which have been inferred from our laws of indices, which are going to be applicable insofar as logarithms are concerned. So I hope that this is going to assist us, of course, in trying to figure out how we can be able to do different calculations using these different laws of indices. And in a sense, it's going to assist us to try and do a comparison with indices and try to see which are some of the similar laws that are applicable for both cases. So we stop there for these laws of indices. Now next, we're going to look at natural logarithms. This is a special case, of course, which we're going to mention pertaining to the concept of the number e, which basically is regarded to as a natural base. So catch us in our next video. I will stop there for today. Bye guys, God bless you.